All right. So, hey everyone, welcome to the very first episode of TechGlam Live. My name is Joe Mejica.
And I'm Doreen Peppers.
TechGlam Live is our new monthly variety show series where you, the customer, get a chance to learn about Cisco technologies in a fun and interactive way.
From live talk shows, lunch and learns, interactive games, and more, we want to bring something new each month.
And for that, we would like to thank all of you for being a part of our pilot episode. And as a way of saying thanks, we actually have a surprise for all the customers who attend today.
For all the customers who attend, we'll be sending you a Cisco prize item, and one lucky winner will be selected from today's audience at random to win a Cisco DNA security hoodie. Hey, Joe, can I get a security hoodie?
Well, unfortunately, you're not a customer, you're my fellow co-host, but one of these days, we'll just have to see what other surprises we have going down the line.
All right, because those are pretty cool hoodies. I wouldn't mind getting one.
Yeah, and actually, I might have it right here. So I'm not lying to you guys. We have a hoodie that we're going to be raffling off to one lucky customer today. So today we're joined by our special guest, Shani Haley, who is our technical solutions architect.
And today's show is all about software-defined access. You will learn what SDA is and how it'll make your life easier through automation. So let's get started.
So Shani, we are so happy to have you on our very first episode of TechGlam Live. How are you feeling today?
Doing great. Thanks, Joe.
Awesome. So Shani, we have, so for today's show, I know we're talking about SD access in particular. So I have a couple of questions just to kind of kick us off here. So can you tell us what the environment has been like, that led us to the need of a policy-based network solution, as well as software-defined access, to basically encapsulate everything that we're talking about today?
Oh, for sure. So there's been a lot of pretty big challenges on the network in the past few years. So first of all, huge increases in the number and types of devices on the network. So rather than just laptops and printers and phones, now we've got mobile devices, BYOD devices, and IoT devices that can't really be secured as well as we'd like. And on top of that, we're seeing some more sophisticated security threats. So things like ransomware, things like encrypted malware. And on top of that, those IoT devices that I mentioned before, they can be very, very simple to hack. They can be involved in botnets and other things like that. So there's a really strong need for comprehensive end-to-end security that really goes beyond just that firewall moat that everyone was thinking about in the past. On top of that, there's complex traffic flows these days. So rather than having everything in the data center and everything going to the data center, we're seeing things like SaaS application adoption, infrastructure as a service workloads, things like that, things that make the traffic flows going through the network even more complex. On top of all of that, our IT teams haven't really gotten bigger. So there's a lot more to do, but usually not very many more hands to do it. So this pace of change is really kind of expanding beyond what our IT teams are capable of handling.
So, Shani, sorry, go ahead.
No, I was just going to say, and along with those problems of, growing work, standard size IT teams is everyone's mostly still doing everything manually, which is introducing the possibility of risk of a typo resulting in a security violation, resulting in a vulnerable network and those kinds of things. So these are the kinds of things that we were thinking about when it comes to software-defined access and what problems we needed to solve.
So I've been hearing a lot from our customers. They're saying that moves, adds, and changes, along with adding all these IoT devices that you were just talking about earlier, all these random devices that are getting on the network, and the difficulty of securing this environment, this is really starting to be a hardship for customers everywhere, right? They're saying it's time consuming and they just don't have the manpower, to your point. So can you tell us how SDA is going to simplify this process?
Absolutely. So the cornerstone of a software-defined access fabric is identity-based policy. Some of those manual tasks that you were talking about, manually configuring the correct VLAN on a port based on what type of device is connected to it, manually creating and managing very large IP-based ACLs, things of that nature, SDA is going to solve for because we're going to use identity-based policy, which means for our networks, our for our client devices, we can use the identity of the user in order to correctly put them in the right segment, give them the right policy. And when it comes to our IoT devices, even if they can't really authenticate, we can still use things like what type of device they are in order to make sure that they're both getting on the network, they have limited access, and we can put them in our own segment. So that's another kind of big piece of software-defined access, is the idea of macro and micro segmentation. So we can break the network up into virtual networks. We can put all of our IoT devices in their own virtual network. And that means that, based on just them joining the network. And what that means is that if the bad guys manage to hack your HVAC system, they are not going to get fully access east-west across your entire network because of that macro segmentation. And then within each of those virtual networks, we will be able to very granularly control what types of communication based on port protocol application that we allow certain groups to have with other groups. So that's going to be a really, really huge thing when we talk about, maintaining that secure posture. And because we're using identity-based policy, it doesn't matter where people actually connect to the network, whether it's wired, whether it's wireless, whether it's building 1 or building 3, they will have the same access everywhere they go.
Awesome.
Got it. So, this all sounds really good. It sounds really intriguing, but, as a customer, how do you actually go about implementing a software-defined network? Like, what is that solution that Cisco is putting out there to make this all happen?
Well, absolutely. So we're going to deploy a software-defined access fabric using DNA Center. Now, there's a lot of really great benefits of DNA Center outside of even SD Access, but when it comes to deploying an SD Access fabric, things to think about is there's a lot of technologies that roll up into software-defined access, control plane, data plane, things of that nature. But DNA Center is going to handle the configuration of that for you, and it's going to use that Cisco best practice prescriptive configuration. So what you have to do is do some planning, figure out what IP addresses you want to use, figure out what devices are going to be part of the fabric, and then you can use DNA Center's UI to kind of go through, define that virtual network to group connection, define that group-based access control policy, identify the devices that are going to be part of the fabric, do a few other things, and then that will help you deploy the fabric. Another part of SD Access that I didn't mention before is Identity Services Engine integration, which is still going to handle that authentication task. However, DNA Center does integrate with ICE and kind of offload some of the heavy lifting around deploying that identity-based policy via using the DNA Center UI.
Got it. Wow, that is awesome. Do you think you can demonstrate how easy it is to build an SD network and how we can create a policy to actually automate the business intent?
Absolutely.
Awesome. That's great. I'm super excited to see this.
All right.
So what kind of device family it supports? They support like ISR 4000, 9000. What type of device it offers? It supports for SD access.
Okay, so there's a pretty comprehensive matrix that's out there on Cisco.com, but just to kind of give you a high-level overview, your Cat9K switches, your ISR routers, your ASR routers for some roles, there is some support for if you go back one level and take a look at like the Cat3Ks. So it just kind of depends on what role we're talking about in the fabric. So we're going to have, fabric edge nodes, border nodes, control plane nodes. And there is some really good details out there about which platforms will do which jobs. But in general, if Cisco is selling it today in the campus, it supports SD access. And if it's something that is still at least relatively current, like the Catalyst 3650 or 3850, that's going to be supported as well. Does that answer your question?
Yes.
Okay. And Doreen, maybe you could throw a link out there to that compatibility matrix or something if you got a moment.
Absolutely.
Okay. Let me go ahead and share out my screen, and then we'll get started with our demo. Okay. So here we have, and hopefully everyone can see that. Doreen, can you see my DNA Center here?
Yes.
Okay, so here we have our DNA Center UI. And like I said before, DNA Center does a lot of stuff besides SD access, but what we're going to be talking today is, how do we actually go through, how do we define that policy, how do we define that fabric? So Our first step that we would do in our DNA Center, SD Access build is that we would add our devices into DNA Center. So if they're already out there, we would pull them in using a discovery, and then we would define a site hierarchy. And then within our site hierarchy, we can go ahead and do things like define our AAA servers, our NTP, our DNS, and things like that, where it aligns to a site level. And then, of course, this is going to inherit down, but if we have differences at different sites, say down here in California, I've got a different set of servers, I can go ahead and redefine that down here. So once we just have this sorted out, we'll be able to kind of move on. The next thing we'll be able to do is define the IP addresses we want to use in our fabric. So that'll be as simple as either defining some IP address pools or connecting DNA Center to your IPAM. And then you can kind of pull in information about the IP address pools that you've created over there if you're using Infoblox or BlueCat. All right, once that part is done, then we can go ahead and start thinking about policy. So our first step when we're defining that macro segmentation is going to be to go ahead and define our virtual networks. A virtual network within an SD Access fabric is going to be similar to the idea of like a VRF. And the idea is that the groups that are in this virtual network are going to have no access, no visibility, and no path to groups in a different virtual network. So what I'm going to do is I'm just going to create a couple of virtual networks here. I created the IoT virtual network, and now I'm going to create the campus virtual network. And it is very simple in order to kind of figure out who needs to be in what virtual network here. So for my campus virtual network, I want my contractors, my developers, my employees to be in this virtual network. And each of these groups that you see here has something called a security group tag or a scalable group tag, sometimes called security group tag, associated with it. And so that's what we're going to use kind of in the back end when we start to make these policies. And then for my IoT virtual network, I'm going to go ahead and I'm going to add my cameras, my HVAC, my lights, and we'll stick it there. So that's what I'm going to have in my IoT VN. So what I've done here is that I have defined my virtual networks, my macro level segmentation, and then I've defined what groups belong to which virtual network. So that's step one. Once we have this defined, our next step is going to be to go ahead and go in and kind of refine further. What we're looking at here is the group-based access control policies, and this is my micro segmentation level. What you'll see is all of the groups that I have defined in my network down the left and across the top. And so what we have here is basically a source destination matrix. And what we can do at that point is we can say, you know what, I would like to see, my lights to HVAC, what I've got going on here. And from here, I can click in, and then at this point, I can start to create policy for how the lights and the HVAC groups should be able to interact. So in my case, I can go ahead and use a contract to define what that particular set of communications should include. So in my case, I've got some contracts that are already made, so just a straight up permit or deny IP, or I can start to slice and dice that a little bit more finely. What I'm going to do is I'm going to create a new contract, and I'm going to call it secure only, because I have a use case in which my lights and my HVAC should be able to talk to each other. So say I have lights with a motion detector on, and when the lights go on, I want the AC to come on or something like that. What I'm going to allow is I'm going to allow, HTTPS, and I'm going to go ahead and I'm going to allow SSH. And I'm using this application here, but if I wanted to, I could actually also just go ahead and use strict TCP and UDP port numbers. So if I have some kind of custom application that's not a name that's in my list, I can still do that, if I wanted to do HTTP and I didn't want to type HTTP here, I could still do port 80, that kind of thing. And then I have my default action here. And my default action is permit, but I want to go ahead and change it to deny. So I am only going to allow HTTPS and SSH between my HVAC and my lights. And then I click save here. And then I can go ahead and pick my new contract for this particular set of communications. Now, it's going to kind of give me a little bit more detail there, and then I click Save. But of course, when I click Save there, it's not going to just go ahead out and just start changing stuff on my network right away. If I want these to actually take effect, then what I'll do is I'll click Deploy. And then at that point, that's when the change actually gets pushed out to the network. So as you can see here, this is just kind of some information about how we would go about deploying policies, keeping in mind that we don't have to make pairwise policies for groups that are in different virtual networks because they don't have the possibility of interacting with each other. Different virtual networks have, different routing tables and all that other stuff. So only for the groups that are in the same virtual network do we go in and we start defining our microsegmentation policies. Just to give you guys a couple of quick looks here at this UI, we can kind of go in and we can see all of our access contracts here. And then we have the ability to go in and see all of our scalable groups here. And during this whole thing, DNA Center is integrated with Identity Services Engine. Like I'm sure you've seen this kind of, green box up here. And what it's telling you is that, hey, we are talking to ICE. We learned everything that ICE knows about the groups, about any types of policies that were created over there already. And what we're going to do is now we're going to take care of this from the DNA Center UI. And you don't have to do this part of it in ICE anymore. But we do have the ability to create new groups. So if we wanted to create a new group and we want to call it like a Tech Glam, and we could go ahead and we could define a virtual network for it already if we wanted to. We want this to be in campus. And then we can go ahead and save. All right, so that's how we would go about creating new groups if we wanted to. So this is kind of how we do the policy part of it. At this point, I'm going to transition over and start talking about how we actually build the fabric. Okay, so I'm going to go over here to my provision and fabric. And when that comes up, what we'll see here is we have the ability to define or edit existing fabrics or transits. And the difference is the fabric is the actual site where you're going to be running SD access. The transit or peer is basically telling the DNA Center how this fabric is going to interact with the rest of the world. And there are a few different types of transits that you can use with an SD access fabric. And that's going to be your standard IP transit, so an IP network, or you can use software-defined access. So you've got the ability to carry that fabric across to multiple sites. And then there's some other options as well that are coming up that you'll probably get to hear about next time. All right, so if we go into our fabric, a fabric can be made up of a bunch of different sites. In our case, we do have a bunch, but what we're going to do is we're going to build a new one. So over here in San Francisco, we have a very small site, and we are going to be able to build in a fabric using only one device because of the ability to kind of collapse roles. So the first thing we're going to do is we're going to go in here to our device, and we're going to say, you know what, we want to assign fabric roles to this particular device. And all right, so we can go ahead in here. And now we see what we wanted to see. First, we can define that we want this device to be part of our border. And so, or we want this device to be our border. So what we're going to do is we're just going to go ahead and define our local AS number. We're going to say, you know what, we want all virtual networks to be able to use this interface, and we don't want to import external routes. So basically, we don't want what's outside of the fabric to get advertised in. And then we can go ahead and just pick our transit. We'll go ahead and pick our SDA transit here. And then we click Add. And then from here, we can just say, you know what, we want this device to also be a control plane node, and we want it to also be a fabric edge node, and we want it to also be a wireless LAN controller for this site. So we can go ahead and click all those, and then we're comfortable with the site that we chose. We click Next here. And then this is just the ability to define the rolling AP upgrade percentage. So how many APs do we want to upgrade at one time? Looks like we're 5%. And then click Next, click Save, click Add, click Deploy. And we'll deploy that now. And what this will do is DNA Center will go out to this device, and it'll start to deploy all of the configuration needed to have this device join the fabric and act as the control plane border node and edge node and wireless LAN controller for this little site here. We're not 100% done yet, though. The next thing that we're going to have here is authentication template, and this is really huge. And I want to talk a little bit about what we're doing with this. So the cornerstone of SD Access, like I mentioned before, is that identity-based policy. What we're doing here, we're authenticating our users and using, for most users, 802.1x authentication. And we have some other options as well. Like we can use, like open authentication, low impact, which is easy connect. Basically, we use AD authentication. But either way, this is usually a whole lot of configuration. This is the really long string of 802.1x authentication configuration that's put on every switch port, that's put on every network device. But we can do this with just one click. Now, what we can do is we can look and say, you know what? Do we want to try 802.1x first and then after 21 seconds fall back to MAC authentication bypass? Or would we rather do it the other way around? So we can go in and kind of switch this around. Do we want to have one host per port or unlimited? So we have these options here. And what we can then do is we can just click close authentication, deploy, apply. What this is going to do is for all of our Fabric Edge nodes, for all of their downstream ports, we are going to configure 802.1x authentication across all those ports with just that click of a button. So this is really, really simplifying that identity-based 802.1x secured closed-off network that we really, really need for that comprehensive security, for that zero trust kind of lifestyle that we want to live. The next thing that we're going to do is we're going to just go ahead and add our virtual networks that we defined earlier to this fabric. So the only thing we really need to do here is just let DNA Center know what IP address pools are we going to add to this fabric. So we're going to add that pool that we created before, and we also have to pick what kind of data it is. And then we click deploy, and we click now. And then we can do that again for our IoT virtual network. We want to use this IoT pool that we defined. We want that to be data traffic. And then from here, we click add, we click deploy. At this point, we are ready to start accepting clients onto our network. And if we need to, if we have some special corner case types of situations, we can actually go into specific ports and make some changes there, maybe assign a scalable group tag or assign a particular virtual network and things of that nature. So now that we've built our fabric, there's a couple other things that I would like to show before we kind of roll out of the demo. So within the group-based access control area that I showed before, we have this other tab called Analytics. And this is one of the parts of kind of refining our SD Access fabric. So we've created scalable group policies. We've created virtual networks, but now we can also use DNA Center to see in that kind of SD Access fabric what actual conversations are going on out there, so that we can refine our policies. So now we have, employees that are having conversations with guests. Is this a problem? Is this something that we need to worry about? Do we need to go in and refine our policies there to make sure that guests and employees don't talk? Maybe we need to put the guests into a separate VN so that we don't have those conversations anymore. So we can still go in and kind of see that. And we can do this for more than just scalable groups. So if we happen to be using StealthWatch, we can do it from scalable groups to StealthWatch host groups. And we can also do this to certain ICE profiles, right? Scalable groups to ICE profiles. So just giving us information here, right? So, HVAC, to guests, should we be having that conversation? Should this traffic be allowed? So it's just going to give us more capability to kind of drill in and see what's available. And then the last thing I want to talk about here is AI Endpoint Analytics. So when we're talking about identity-based policy, one of the things we're talking about is identity. So in the case that we have those IoT devices, those capabilities that we want to be able to properly identify them so that they can be put into the right group. But sometimes we may not have all the information we need. Identity Services Engine has a lot of profiling capability, but what we can do with DNA Center is we can expand that. We can use deep packet inspection and other capabilities on the Cat9K switches in order to help fill in what an unknown device is. So we can start to do things like recognize devices by hardware models, recognize that a device is an MRI machine, things of that nature. And we can make use of the capabilities that DNA Center has in order to kind of advance and improve our our capabilities around identification. So the ability to kind of use that AI and ML capability and the crowdsourcing to go in and say, you know what, according to the information that we have, these types of devices are, coffee machines or Apple Watches or something like that, and be able to help you push that information in so that you can more properly make your identity-based policy for things. Okay. Yes.
Shani?
Yes.
So this is Kevin here. Great stuff. I was I was interested in that matrix you brought up earlier, where you were showing the matrix with the different groups and so forth.
Okay.
So for healthcare, right? And often in healthcare, right? There's a struggle there to make sure that there's security, interoperability, all of that. But at the same time, if there's going to be some IoT, you discussed IoT earlier, right? Some IoT devices that are brought on the network, and that network, exists in multiple buildings, in multiple cities, and so forth, right? And we want to keep all of that segregated. We don't want any of that traffic to interfere or interact with any of our other users or traffic that's on our network. I think you're explaining this is in this matrix here, how easy it is to do that. Can you maybe go into a little bit more detail there?
Well, absolutely. So if I had those IoT devices and I wanted them to have absolutely no contact with any of my medical devices, I would probably just go ahead and put them in a separate virtual network. However, if I was in a scenario in which I had to have my IoT devices and some other types of devices in the same virtual network, and I wanted to kind of make sure that they didn't have the ability to talk to each other, then what I could do is I could just go in here and I could, kind of pick a certain one here. So let's say, I don't know if I have anything good from a medical device point perspective here. But what I could do is I could just take, finance servers, and we'll just kind of sub that in for our network device type, or our medical device type. And I will say, you know what, I don't want them to have any kind of conversations with, this other group that bothers me here. So I can just go ahead and pick the deny IP contract, and then I could click change here and then save. And what that is going to do is it's going to give me the red box. And the red box basically means, no conversations allowed. Does that kind of cover what you were asking?
Yeah. So there's the quick way, right, which is the virtual networks, right, which is all or nothing. And then what you're showing here is groups. And where are these groups derived from?
Okay, so there's two places. If you already had them defined in an identity services engine, then all you would basically do is you would link ICE and DNA Center together, and then DNA Center could learn them from ICE. However, if you wanted to create them here, then all you have to do is go to scalable groups here and then just create scalable group. And then you could define a name, you could define other things like that. Now, if you already have other sets of groups that you're using in something like Active Directory, then you can link Active Directory with ICE and then have ICE learn some things from Active Directory and then just kind of push them across to DNA Center as well. So there's definitely multiple options for how we do that.
Oh, that's good. Nice. Thank you.
So any other questions out there? And Doreen, did I cover everything that you wanted me to cover in terms of the demo?
Absolutely. Yeah. I mean, unless if there's something someone wants to see that's specific, I think you hit it on the nose. That was really awesome stuff.
Awesome. And I'm sorry I turned off my video. I started having some slowness on my computer. I can turn it back on.
All good. Yeah, I mean, just as as an overall use case, I can definitely see how this can, I guess, simplify a lot of these operations, right? I think the biggest use case is, traditional access lists. I know I fat fingered a few. Luckily, it wasn't in production, but I'm sure all of us have been in that position before. But I know this can definitely help, mitigate some of those more redundant tasks out there. Did you have any, what are some of those, I guess, Doreen, did you have any of things you also wanted to add on your experience of using this tool?
All I could say is that when I was in operations, I didn't have DNA Center. I didn't even know about SDA. I didn't know about any of this stuff. And everything was manual. Everything was like touch your switches, touch your routers, write your ACLs, update your firewalls. Everything was manual and cumbersome. And then, to Joe's point, fat fingering. And then you wonder why things don't work. If I knew about this when I was in operations, I would have been all over it telling my management, we've got to do this. This is the way to go. And here are the reasons why. So I think this thing is absolutely amazing. And I wish I had this when I was in operations. That's all I could say.
Yeah, and I think another thing I just thought about too. So ironically, I'm wearing a DevNet shirt. I know Cisco's really big on programmability, but Shani, like, could you? I think I heard about this, but DNA Center, you can run APIs and basically run scripts against a lot of this functionality. Is that true?
Absolutely. So programmability, as far as we're concerned here, programmability is definitely the future. And so there's definitely kind of like an API focus when it comes to our product. So when it comes to DNA Center, pretty much everything that you want to do, not 100%, but very close to 100% of the things we do with DNA Center can be done via API. And there's some really great API documentation, like the Swagger type API documentation available within DNA Center, and a bunch of resources on DevNet to kind of help you get started. But you can do things like zero-touch provisioning, you can do software image management, you can modify your fabric. A lot of that stuff you can do using DNA Center APIs. So definitely a huge thing. So if you're definitely on the higher scale of things, or you really love programmability, DNA Center can be like that one touch point. So rather than having to, make those API calls and netconf yang models to every single device individually on your network, you can kind of just point towards DNA Center, and DNA Center can do the talking to your infrastructure for you.
Awesome. That's really good stuff. So I think what we'll do here is let's open it up to the audience. Does anyone have any questions for Shani while we have her on the line?
Hi, I have a question for Shani. Can you please talk about the scenario where there are multiple sites, where let's say you have a guest network, but the guests are the same policies you want to apply for multiple sites? How you address that?
Well, absolutely. So when you create policies within DNA Center, they can apply to any sites that you define. So the policies that I created were not, kind of based on one site or another. It's just a matter of, do you have those groups and do you have those virtual networks at those sites? And if so, then these policies will apply to all sites. And when it comes to guests, there are a couple of things that we can do in an SD Access Fabric for a guest network. So you can define, like if you wanted like very, very strict separation between your guests and the rest of your network, then you could define separate borders for your guests only. So for each virtual network, you do have the ability to kind of define like a different traffic flow. Or if you wanted all of the guests in your entire enterprise to go out one specific site and right out into the DMZ, you do have that kind of flexibility. So you can make guests, like for some kind of lower security kind of customers, you can make guests just one more SGT. It's like an unknown, everyone gets guests, right? Or what you can do is you can define guests in an SGT in their own VN, give them their own border and control plane node, and stick them out onto the DMZ where they don't actually reach the rest of your network. This just kind of depends on what level of segmentation you want from your guests. Does that answer your question?
Yes, it did. Thank you.
Okay.
It's a good question. We'll take a couple more questions from the audience. Does anyone else have any other questions they would like to ask?
So what kind of code it goes push out to the device, right? It must be pushing some kind of a changes to the device. Do you have a sample code that configuration changes it does to the switches?
So not off the top of my head, but I can give you a very quick explanation. So if you want, you can go out to ciscolive.com, and there's a couple of presentations out there where it'll kind of go through the code. But depending on what device role you have, so is this an edge node that's going to connect to endpoints, or is this a border node or control plane node, you're going to have different CLI configuration. But underneath the hood, software-defined access is a protocol called Lisp, VXLAN as an overlay, and the 802.1x trust set configuration. So those are going to be the things that are on your edge devices, the ones that are connecting directly to your endpoints. And then for your border devices, you're going to be looking at that Lisp control plane, that VXLAN, as well as some BGP northbound. So those are the kinds of things that get pushed to the network devices based on what you kind of configure as what SD access role gets configured on the device.
Okay.
Does that answer your question?
Yes.
Okay.
It's good questions. I think we'll take a couple more if there's any. All right. So I think we're good. So everyone, awesome questions. We appreciate the interaction. Of course, if there's any additional resources, we can, let Shani know, but of course, also reach out to your fellow account manager and SC. I know this was like a segmented conversation, but we're always more than happy to continue this, especially if it makes sense for your overall infrastructure. So that's something that we definitely want to continue on. All right. So with that said, we are at the closing part of our episode today. So I think what we'll do here is, we're wrapping things up. I guess in behalf of, TechLam Live, thank you for everyone that attends, our customers, our Cisco team. Shani, you're awesome. Thank you so much for your presentation. And we're just overall excited. This is our first episode and we are continuing to do these every single month. So stay tuned for all the exciting things we have going on.
Absolutely. Thank you again for attending, everybody, and have a fabulous day.
Excellent, everybody.
Thank
Stay
you.
safe.
Take care.
All right. Bye-bye.
Thank you.